Distinguished ladies and gentlemen, I want us to look at indices. And basically, I want us to start with the laws of indices before we proceed to solve indical equations. Before we proceed to look at indical equations and how we can solve them or how we can simplify, that is, indical expressions. Indices in singular is index. Index. The singular of indices is index. An index is the power. Now, I want us to look at the laws of indices. I want us to look at the laws of indices. The first law is this one, that is x raised to m times x raised to n. That is the first law of indices. We can also say that the multiplication law of indices, because there is a multiplication sign in between x raised to m and x raised to n. Now, this one can be simplified and written as x raised to m plus n. The reason why we write that way is because when we have the bases, this is the base and this is the power. This is the base and this is the power. The bases are the same and there is a multiplication sign in between. Therefore, we take one of the bases, then we add the powers. Now, number two, that is the second law of indices. That is x raised to m, then divided by x raised to n. That is x raised to m divided by x raised to n. Now, in this case, the bases are the same. That is x and x. And there is some division sign in between. Therefore, we minus the powers. That is, we shall have, that is x raised to m minus n. Now, that is the second law of indices. We also have others. Let us proceed to look at other laws of indices. That is the third law of indices. The third law of indices is x y raised to m. That is xy, close the bracket, raised to m. That is the third law. Now, this one, we can simplify this one basically and have it as xy, then close the bracket raised to m. That means x and y, they share this power. X and y, they share that power. Therefore, we can say this one can be x raised to m multiply with y raised to m. That is just how we can simplify this. Or you can have also a question that is in this form, and how do you combine them? Since they have the same powers, you just take x times y, which is xy, then you raise to m. Now, we also have another law. That is the fourth law of indices. We also have the fourth law of indices. And the fourth one is x raised to m. X raised to m. Then we close the bracket, raised to n again. This one is just, it will be x raised to m times n. We multiply the powers. That is x, x raised to m n. That is x raised to m n. So This is x raised to m, then we close the bracket raised to n. Now, we can just take it as x raised to mn. That is, we multiply the powers. We multiply the powers. Now, we can look at, that is the fifth law of indices. We can look at the fifth law of indices. We can look at the fifth law of indices. And the fifth law of indices is the zero index. That is the zero power law, or the zero index. That is, the power is zero. So this is the fifth. This is the fifth law of indices. Now, in this case, we have x raised to 0. I want to say this in this law. Any unknown, any number raised to 0 is 1. Even if it is 1 million raised to 0, it is always 1. Even if it is 1,000 raised to 0, it is always 1. Even if it is x or y or m or t raised to 0, it is always 1. Therefore, in this case, this one is just 1. This is just 1. Now, we have the sixth law of indices. The sixth law of indices is 1 over x, 1 over x. Now, in this case, this is just basically x raised to negative 1. Because of 1 over, we introduce a negative. That is, because of over, we introduce a negative. So we shall have, this is 1 over x, so it will be x raised to negative 1. Now, we can also have the seventh law of indices, the seventh law of indices, and the seventh law of indices is just, that is 1 over x raised to m. This is just this way. It is almost close to this, but this is how we write this one. It is x raised to negative m. It is x raised to negative m. So this negative, then that is this over can be expressed in terms of, that is negative. So we shall have, this is 1 over x raised to m, so it will be x raised to negative m. X raised to negative m because of this 1 over. Now, that is the seventh law of indices. Now, we can look at the eighth law of indices. That is number 8, law of indices. Number 8 is just x raised to, this is x raised to m over n. X raised to 1, that is x raised to m over n. So this one will be, that is the square root, not even the square root, but the nth root. The nth root of x, then raised to m. That is the nth root of x raised to m. So this one, that is x raised to m over n, that is the power is a fraction, m over n. So you first find, that is, you consider the, that is the integer. You consider the integer that is on the denominator in the power. So you will take it as the nth root if it is n. But if it is p, the p root. So if it is, maybe the integer is 5, so it will be the fifth root of this. Then the power, which is m, that is the power that is in the numerator, that is like m, you raise to m, that is outside the bracket. After finding this one, you raise to m. The whole of this raised to m. Now, Uh, the ninth law of indices, the ninth law of indices, the ninth law of indices is just x. It is x over y raised to m raised to m. That is the ninth law of indices. That is x over y raised to m. Now, in this case, it is just the same as x raised to m over y raised to m. It's just as simple as that. Now, the last law of indices, that is the last one now, the last law of indices, we want to look at it. The last law of indices. The last law of indices is just, that is number 10. It is x raised to 1 over n. That is x raised to 1 over n. So in this case, it is just the nth root of x. 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 That is the last law of indices. That is the last law of indices, which is number 10.